in this video we are going through the 2016 November Maths grade 12 paper 1 exam. So all the questions, we're going to answer them from start to finish without leaving anything out. So without wasting anyone's time, we're being asked to solve for x here. It's a 2-mark question, simple, straight to the point. Fortunately, this is already factorized. Now, because they are saying each of these is equal to 0, or each of these multiplied together is equal to 0, the idea is you're going to make the first expression equal to 0, and then the second one you also make it equal to 0. The reason for that is if this multiplied by that is going to give you a 0, one of them is potentially a 0. You see, because anything times 0 is going to give you a 0. So this is our first answer. Our second answer here, we're just going to say x is equal to 7. Moving on for 2 marks, and then here 3 more marks, right? Any question that starts like this, where they're asking you to write it out correct to 2 decimal places, what they're literally trying to tell you is that you need to use your calculator. You see, you need to use the quadratic formula. So you using the quadratic formula, this is something that's on your formula sheet. And then this format is in the format ax squared plus bx plus c. B is the -6 over there. And then you're going to throw that there as well, -6 squared. Your a value is this value in front here, which is just, what is this value in front here? It's just a +1, you see. So this is just a +1. Your c value is a +2. Your a value down here is just a +1. So all this in your calculator, let's see what that gives you, you see. So in the calculator, we're getting here, let me just get this calculator nicely so that we can put everything in there properly for all of us to see. So we have here -6 plus square root of -6 squared minus 4a, c value is a 2, the bottom here is a 1 times 2. So this is giving us an answer of 5.65, or our x value is equal to, what's the other one here? It's giving us 0.35. So those are our 2 answers. Those are our 2 potential answers for x. Question number 1.1.3, it looks like it is pretty straightforward. However, this 5-mark allocation here, and also us having a square root symbol, I mean, like if you've gone through enough past papers within this question papers channel, you'll notice that questions like these, they mean that we're normally going to need to double check our answers to make sure that we have disallowed whatever answer is not valid. So solving for x here, you may want to leave this expression on its own, right? The reason for doing that is if you are going to get rid of the square root symbol here, the one way to do that is to square both sides. The opposite of square rooting is squaring. But because it's an equation, what you do on one side, you have to do it on the other side. What happens is on the left, the square root cancels the square. You have x minus 1. Here you have what we can just multiply by itself like this twice, you see, because automatically what you have here is x multiplied by x, which is like x squared, x times -1, which is -x, another -x, and then a +1. So here, oops, made a mistake. This is supposed to be x minus 1. So obviously, we have here x minus 1.
As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
And then this is like x squared minus 2x plus 1. This is like x minus 1. And then we are going to take everything on one side. Taking everything on one side, we're going to leave this left side with the 0. We're going to have here x squared. Negative 2 minus x. It's like negative 2x minus x. And then here we have plus 1. And then plus 1 here also. So obviously, with all this being said, we should have here x squared, negative 3x, and then positive 2. This is equal to 0. So if you're going to solve for x here, we need factors of 2 that can give us a 3. Factors of 2 that can give us a 3, it's just 2 and 1. But to get a negative 3, we have to say minus 2 and minus 1. Unfortunately, minus 2 times negative 1 gives us a plus 2. So here, you can say the first bracket, right? You make it equal to 0. Second bracket, you make it equal to 0. And then solving for x here, the 2 is going to go over to the other side. It's a positive 2. This goes to the other side, it's a positive 1. So because there is this square root symbol here, you have to double check your answers. So we're using 2 and 1. So if you put a 2 there, right, it's going to be 2 minus 1 plus 1. Let's see if this is equal to 2 because we're just throwing in 2 where x is. So 2 minus 1 is a 1, 1 plus 1 is a 2. So yeah, the left side here balances the right-hand side. So the 2 works out. In a situation like this, the 1 is likely not going to work because if you put 1 here, it's going to be 1 minus 1, right? Or rather, 1 minus 1 is a 0. And then, oh, the 1 also works. Dang it. Whoa, okay. 1 minus 1 is a 0, square root of 0 is 0. Then 1 is equal to a 1 because x is a 1. Okay, this would be worth 5 marks. So both answers work. So we leave both. But always just double check when you have things that have square root. Here, this is a classic question where we're going to use the K method. This is a kind of an example where you can see that the only big issue here is the 3 to the power of x. You have 3 to the power of x here, you have another 3 to the power of x here. So obviously there's a plus 2 here, and there's a plus 3 there. However, this is what you do. This is what you do. In a situation like this one, you're gonna need to take out x to the power of, 3 to the power of x, right? What's gonna be left here is 3 to the power of 3. If you take out 3 to the power of x here, what's gonna be left is 3 to the power of 2. And then you have 4, 8, 6. So in a situation like this one, this is 9 minus, 27 minus 9. 27 minus 9. This is 3 to the power of x. This is equal to 4, 8, 6. So all this being said, all things considered, 27 minus 9 is going to give us 18. This is 18. This is 3 to the power of x. This is like 486. So obviously we're going to divide both sides by 18. Divide by 18 here. Divide by 18 there. And then we're going to have here 3 to the power of x, right? This is equal to 486 divided by 18. So yeah, let's just see what the calculator gives us. 486 divided by 18, that's going to give us 27. So the fortunate thing with 27 is that this is just 3 to the power of 3. So your x is just equal to a 3 because you can drop the bases here. X is a 3. Now if you test out your answers, 3 plus 3 is a 6. 3 plus 2 is a 5. Now if you say 3 to the power of 6 minus 3 to the power of 5, does it give us this answer? Doesn't look like it does, eh? So we have to just double check our answer. because our answer does not seem right. It just seems so wrong, actually. The reason why it seems so wrong is because it just doesn't seem like it's balancing out, you know? The act is just doesn't seem like it's balancing out. But let's check it out. Let's check it out again. Let's see. 3 to the power 5. Oh yeah, I think it will work out. No, it will work out because 3 to the power 5 is quite a big number. Because 3 to the power 5 is like 1, 2, 3, 4, 5. 3 to the power 5 is like 2. It doesn't work out. It does not work out. Like seriously, 3 times 3 times 3 times 3 times 3. That's like 400, 250, 243, right? And then here we're subtracting a specific number. This minus this. You're 486. Doesn't seem like it's working out, you know? So sure, 3 times 3 times 3, that's like 27 minus 9. Yo, what's going on here? Come on, bro. Why is this question all of a sudden just seeming so weird? Yeah, because it doesn't want to balance out. That's the issue. It really doesn't want to balance out because here, oh, it's 3 to the power of 6. Come on, bro. Come on. 7. Oh, yeah, it does work out. 726 minus that number is definitely going to give us 486. Yeah, so just don't leave your answers hanging, you know. Just double check them wherever you can. Question 1.2 here, we can see they want us to solve for x if f of x is equal to 0. So just a straightforward question, this one. As straightforward can be, really, because there's no catch. There's 0 catches with a question like this one. So here, this question, we're going to make it equal to 0. X squared plus 3x minus 4 equal to 0. Factors of 4 that give a 3. X. Factors of 4 that give a 3, it's like 4 and 1. And then you have here positive 3, right? You're going to have to say positive 4 minus 1. So you're going to say x plus 4 is equal to 0. That's your first option. X minus 1 is equal to 0. That's your second option. Here, the 4 is going to go over. That's minus 4. The 1 is going to go over. That's a plus 1. So both things considered, 2.2.2. 1.2.2 says solve for x if f of x is smaller than 0. Yeah, we have to solve for x if f of x is smaller than 0. So we want to work out where is the parabola having y values that are smaller than 0. This is what the translation here is, where the y value is smaller than 0. So whichever way, right? This is like copy. This is like paste. So with all that being said, if you're going to work out where this thing, right, is below 0, let's say here smaller than 0, right? So if you're going to work out where this is smaller than 0, you need to think to yourself, okay, this is a smiling parabola. So you draw a smiling parabola. And then you have to draw like a mini x-axis. So the fortunate thing is these are the two x-intercepts of our graph, -4 and 1. So somewhere here you're going to have -4, somewhere here you're going to have a 1. So if they're asking where is the graph below 0, right? It means that you are going to choose this part here. Yeah. The part where it's below 0, it's where x values are between -4 and 1. So your x values have to be bigger than -4, or those same x values need to be smaller than 1. You can write it like this. You can write it as one long line. It doesn't matter. It's all up to you. You see, another person would have written it out is they would have said x is bigger than -4, but x is smaller than 1. Another way they could have written it is they would have said something like x is an element of -4 up until +1. The reason for the round brackets is because we're asking for weights below the weights below the x-axis instead of weights also equal to. So because it's only asking for weights below the x-axis, we only consider from -4 to 1. 1.2.3 says determine the values of x for which the first derivative is bigger or equal to 0. So when they're talking about the first derivative, they're talking about the gradient. You see, they're talking about the gradient. So if they're talking about the gradient, what you need to consider is the fact that the gradients are split up by the turning point. On the left side here, the gradients are negative. The moment you pass the dotted line, the gradients will be positive. You see, so what I'm basically trying to say is all these here are negative gradients all the way until there, and then all these here are positive gradients all the way until there. So, all that being said, right? We have to think to ourselves, where are the gradients above zero? So it's this part, the other side of the turning point. So the fortunate thing is we can actually use our x-axis to help us, because if this is -4 and this is 1, the middle here is the middle of the two x-intercepts. So -4 plus 1, you have to divide by 2 to get the middle. So this is going to be like -3/2. That's what the middle is. So towards the right of -3/2, that's where you have positive gradients. So, and it's going to be equal to 0 starting from the -3/2. So your answer for 2 marks, you're going to say your x values need to be bigger or equal to -3/2. Because that's where the gradient is bigger than 0. Because remember, the first derivative means gradient. So if you want to know what is the sign of a gradient, is it a positive gradient or a negative gradient? Just think as though you're walking from the left. If you're walking from the left, right, you're going to be walking downwards until here. Then you start walking upwards. So depending on whether you're walking down or whether you're walking up, your gradient will either be negative or positive. Let's move on. Let's see if we're gonna. 1.3 says you have to solve for x and y simultaneously. So I mean, this is quite straightforward. Wherever x is, it's going to be equal to 2x. So in the equation here, wherever we see x, we're going to throw in the 2y. Yeah, I meant 2y, not 2x. So here, we're going to take equation 1, throw it into equation 2. So the way that's going to look is we have 2y squared, then we have -5, and then this is like 2y. And this is like a y, it's like a -24. And then all things considered, 2 squared is a 4, y squared is y squared. Y times y is y squared. -5 times 2 is -10. And you have y squared. Equal to, here you can just move it over, it becomes no, let's keep it where it is because it seems like it's going to be okay there. So here we're going to take out, it looks like we can take out, these are like terms, so 4 minus 10 is going to be -6 y squared. Then we can divide by -6 on both sides. If we divide by -6 on both sides, we're going to have here y squared. This is like a +4. And then obviously you're going to put a square root symbol here. Your answer is going to get plus or minus 2. So there are values of y. So once you have your values of y, right, you're going to have here x is equal to 2 times -2, or x is equal to 2 times +2. This is like a 4. This is like a -4. You see. So that's what we need to do. 1.4, that was done. Let's move on to question 2.
As of this recording, the all access pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the all access pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
Question number two. Number two says, given the infinite arithmetic series, you have negative, the finite. Oh yeah, of course, because if it's finite, definitely has to be arithmetic or a geometric series that does not converge, meaning it's going higher and higher. But anyways, here they said we have this finite geometric sequence, right? It says write down the fourth term. Well, I mean arithmetic, right? So this is just reducing by 4, reducing by 4. Fourth term is going to be equal to -7. Easy mark. Calculate the number of terms in the sequence. So the thing is, this is the first term. This, you don't know what position this is, but you have every information to find out what the position is here. So to do that, you can use the general term of an arithmetic sequence, which is on your formula sheet. A plus n minus 1 d. Our value of a is a specific value, which is like 5. So you have 5 here plus. N is what we're looking for. Tn is 87. No, minus 87. So what we're doing is we're looking for where minus 87 is. So we put it where Tn is, because this is the actual term. This is its position. This is the common difference. And this is the first term. First term is a 5. We're looking for the position of -87. And we're looking at a common difference of -4. So you just have to solve for n here. -4, you multiply inside, you have -4n. You multiply inside, you have +4. -87 here. 5 plus 9 is like 5 plus 4 is a 9. So this is like you can take the 9 over to the other side. -87 plus the 9. No. You're gonna minus the 9, my guy. You're gonna subtract. So to be honest, the one thing to always really look out for, right, with any kinds of questions is one thing to always look out for with whatever kind of question you always ever need to answer. Just focus on what your signs look like, because your signs will definitely throw you off if you're not careful. So this here divided by 4 is -4 divided by -4. And then you are going to have here the following, right? -96 divided by -4. 96 divided by -4, that's like 24, right? So n is equal to 24. Great. So we know that there are 24 terms, therefore 24 terms, because -87 is in position 84. Is in position 24. The next one says calculate the sum of all the negative numbers in the sequence. So the idea is, if you're going to work out the sum of all the negative numbers in the sequence, funny enough, you can see here that the negative numbers start from -3 up until -87. So you could think of a sequence that starts with like -3, -7, -11, going on until -87. So that sequence, right? You know that from here to here, this is T1, this is T24. So if you're starting from 3 until 24, you're actually dealing with 22 terms, because you'll be excluding this one, you'll be excluding this one also. So from -3 up until -87, that's about 22 numbers. So what we know is, in our sequence here, there's a total of 22 numbers. In our sequence here, our first term is -3. In our sequence here, we have a common difference of -4. In our sequence here, this is an arithmetic sequence, so we can use the SN formula to work out the sum of all these values here that are going to be negative. So n over 2, 2a plus n minus 1d. This is the formula that you use to work out the sum of all the terms in your sequence from a specific position up until a specific position, you see. So in this situation, we would be looking at this sequence that we're given as something totally new, starting from 3 going onwards, you see. which is what you always want to be able to do when you deal with the maths questions. Make the question your own. N here is 22. A is a -3. N is a 22. D is a -4. So obviously this is the kind of equation where you may want to just throw everything in the calculator. You can throw everything in the calculator, get your answer. You really are in a better spot if you do something like that. So the reason I say you can just throw everything in the calculator is because it's definitely something that you want to get used to, because you don't always want to think to yourself that you have to write step by step and all that. But if it's something that like calms you and makes you feel like, you know, you have nothing that they can penalize you for. If that's how you feel and you really, really cannot find yourself putting everything in the calculator and then just giving an answer, if that's you and that's how you feel, that's 100% okay. Because in an exam, you need to make sure that you are as comfortable as possible. So you need to be doing whatever it is that you need to do to make sure that you yourself is as comfortable can be. You know, that's the hack when it comes to what? When it comes to what you may call, when it comes to writing exam papers, you just want to make sure that you're comfortable, you're happy, and that everything is vibing. So the answer here is going to be -990. That's the sum of the first two terms here. So yeah, this question, nothing crazy, nothing major. It is all nice, it is all dandy, and we shall carry on doing all that we need to do because, yeah, man, life is good. LG. The next question here says, consider the sequence, right? It's the same sequence. Now we're going a bit further. So this same sequence says, determine the number of terms in the sequence that will be exactly divisible by 5. This question is a very, very unique question. Unique, but straightforward, but repeatable. So these are the kinds of questions that they normally like to ask, and you just need to know what to do when they ask you something like this. So when they ask you something like this, you have to remember that in your sequence, there are numbers that are going to be divisible by 5. And you want to see after how many terms you get that. This is what I mean. You're going to start at 5, right? And you go to 1. Write out quite a few of the terms visibly. -7 here, -11. We're going to jump like 4 again, right? So that's like -15, -19, -23, -27, -31, -35, going on and on. So if you look at numbers here that are divisible by 5, you have 1, and then you go some more, you have 2, you go some more, you have 3, going onwards. This is like -35. So if you look, right, this is after every 1, 2, 3, 4. Every fifth number is divisible by 5. You see, 1, 2, 3, 4, and then another fifth number divisible by 5. So you can think to yourself, okay, fine, you have a sequence where there's a 5, the next number is -15, the next number is -35, going onwards. So since you know that your sequence here, right, it ends at -400 and -4187. What you need to do is, for you to find out the last number that is going to be divisible by 5, what you need to do is you need to start from this -4187. You need to work your way backwards until you find the last number that is divisible by 5. So working your way backwards, you will just be looking at adding 4 instead, because remember, going this way, you're removing 4. So if you're going to go backwards, you have to add a 4. So from where you are now, right, if you're going to add a 4 here, it's going to be -4,179. That's what it's going to be. Let's see, 4187. If you add a 4, no, it's going to be 83. -4,183. This is not divisible by 5. So you have to go back again. You see, so let's add another 4. Add another 4. This is -4,179. So you go back again, right? Let's see here, +4. This is -4,175. So a situation like this one, you can see that for us to find, we have to know that whatever happens, this is going to be the last number divisible by 5 in this sequence that we're imagining. So it's going to go up to negative 4,175. So what you do is you want to now consider this as a new sequence, where in this new sequence, this is your first term, this is your last term, right? And then in a situation like this one, if you're going to work out the number of terms that are exactly divisible by 5, you know they start here and they end there. So you can just work out the position of this value in this sequence, you see. So the position of this number in this sequence, it's an arithmetic sequence. So we can just use our Tn formula. Tn is equal to A plus n minus 1d. Now for this sequence, our common difference is quite straightforward. It looks like it is minus minus 20. Yeah, minus 20 all the time. So we have D, we have A, and we have Tn, because we want to find the position of Tn. So negative 4,175, A is a 5, N is N, D is negative 20. So multiplying inside this bracket, you're going to have here 5 plus negative, no, you're going to have 5 minus negative 20n and then plus 20. And then negative 4,165. And then here you have this, you can take it to the other side so it becomes a positive. And then 5 plus 20, that's 25. And then this goes to the other side, that's 4,175. So this is going to give you 4,200. Is it really? Yes, it is. Okay, that's weird. Divide by 20 on both sides. What are we going to get here? This cancels this. You're going to have 210. That's what n is. So you have 210 terms that are exactly divisible by 5. So that's quite an interesting question. And you see the way we did it, it was methodical. So this method is something you use for all kinds of questions like these, whether they ask numbers that are divisible by whatever. All you do is you write out your sequence as much as you can so that you see that how many intervals or after how long do you get a multiple of whatever they're asking for. And then you create a new sequence and then you answer whatever question they're asking. So let's move on.
As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
Question number 3, they said, the first 4 terms of a quadratic number pattern are, okay, let's see what these first 4 terms are. You have that negative 1, x, 3, and x plus 8. So it's a quadratic number pattern. Already they have told us quite a lot of information just by saying that. So because it's a quadratic number pattern, there's definitely quite a lot that we can do. So what we need to do here is, if they're going to ask us to get a value of x, you have to use information to do with the quadratic number pattern. So information about a quadratic number pattern is the kind of, what I mean by using the information of a quadratic number pattern, I mean that any quadratic number pattern, you have to remember that if you're going to solve for x, use the fact that a quadratic number pattern has a second common difference. So when you solve for something, you need to find a way of creating an equation. Now the equation we're going to create here is based on the fact that the second common difference is equal. You see? No, but when I say common, I'm already saying it's equal. So, oh wow. Let's just say second difference is equal, or second difference is common. But second common difference, all I'm trying to say is what we do know is that if you take this value minus that one, right, you'll have here x plus 8, and then you just subtract your 3. You have nothing there. 3 minus x, you can just say 3 minus x. And then this one here, x minus negative 1, it's going to be x plus 1. Now, what you do know is when you go a stage further, you will be able to create certain equations, you see. So these equations, you're going to say this whole thing here minus this one. So you're going to have here x plus 8. You're going to subtract this, right? So just like 3 minus x. Then here you're going to have 3 minus x, right? And then you're going to subtract this whole thing here, x plus 1. So what you know is this minus this, which is this value here, is equal to this minus that, because that's what the second common difference is. The second difference is the same. So we can work this equation out. Working it out, we can just say here, can just remove the brackets actually. So here x, we have 8 minus 3, right, which is like a 5. And then you multiply inside here, negative 3 plus x. Here, you can see brackets are important, because the moment you don't have brackets, this whole thing is messed up. So here, you can take everything on one side and then see what happens. So here we have negative 2x, 3 minus 1, that's like a positive 2, x plus x, that's 2x, 5 minus 3, that's a plus 2. And then, oh no, we made an error. The reason why you know you made an error is because things are just bombing out. Your expression is not supposed to bomb out, you know, because here it is bombing out. No, it's not. Ha ha ha. If you take everything to one side, it'll be fine. Oh yeah, plus 2x. And then, 2 minus 2. Okay. Okay, I guess we're still okay, but it still feels a bit wrong because x is a 0. Can x be a 0? If x is a 0, we have, let's see, negative 1, 0, 3, 8. So if you're gonna jump, well, if x is a 0, let's see if this balances out. 0 here, you have 8 minus 3, right, which is a 5. 5 minus 3, it's gonna give you a 2. Here, if you have a 0, it's like 3 minus 1, which is a 2. Okay, so x is a 0. Wow, discriminating against the 0 here. So, yeah, no, we have to divide by 4, bro. X is a 0, that's what we're getting here, so it is what it is. Dizozo, madam. Dizozo. Yeah, so all this is all good. Let's move on. 3.1.2. If x is a 0, they just confirmed it fast. If x is a 0, determine the position of the first term in the quadratic number pattern for which the sum of the first n first differences will be greater than 250. So you can see this question is quite packed. So we're obviously going to read it like twice, thrice if need be. But what you do is you obviously want to see your sequence first, and then we'll reread the question. So when you've read a question like this and it feels like it has just knocked you out a bit, if it's really something that feels like it's a bit annoying you, the best you can do is to just move on with your paper and then always come back to this kind of a question later. Because the thing is, in an exam, you want to preserve your mood. You see, you want to preserve your mood. It is very important. So it says here, if x is equal to 0, Determine the position of the first term in the quadratic number pattern for which the sum of the first n first differences will be greater than 250. So we said you may want to lay out your sequence, and then after laying out your sequence, the idea is you want to visualize what the sequence of first differences looks like. So the sequence of first differences, you're going to have 8 minus 3, which is a 5, 3 minus 0, which is a 3, 0 minus negative 1, which is a plus 1. So the idea is your second common difference here is obviously a 2, 2 and a 2 over here. So if you think of what they have told us, they said if x is a 0, determine the position of the first term in the quadratic number pattern for which the sum of the first n first differences will be greater than 250. So you say the term in the quadratic number pattern. So what we're dealing with is a term in this original sequence here. And we need to find out which of those terms determine the position. We have to find the position of a term in the quadratic number pattern for which the sum of the first, or for which the sum of the first n first differences will be greater than 250. So it just means in our sequence of first differences, we're adding them up. And we want to add them up until we see how many terms do we need to add up for us to at least have 250. You see, that's what they're asking us here. Determine the position of the first term of the quadratic number pattern for which the sum of the first n first differences will be greater than 250. So we're going to work out how many terms here give us 250, right? And then, or how many terms here do we need to add up for us to start getting anything above 250? Once we find out how many those terms are, fortunately, what you need to keep in mind is if you have added up, let's say 2 terms, right? You adding up 2 terms, you will need to have been working with term number 1, 2, and 3 of the quadratic number pattern. You adding up 3 terms, you would need to work with 4 terms in the quadratic number pattern. So in our example here, if we find out that we need to add up, let's say 15 terms, it means that the value of the position of the sequence in our quadratic number pattern will be in position number 16. But let's not overthink it for now. Let's actually just work out in this sequence how many terms need to be added up for you to get 250. Fortunately, to do that, you can just use the SN formula. You see, the SN formula for an arithmetic number pattern or quadratic number pattern. This is an arithmetic number pattern because it is a common difference, you see. 2a multiplied by n minus 1d. We don't know what n is, but we know we're trying to add up until 250. So we have n open. A is a 1. Our common difference is just a 2. No. N is open, bro. Our common difference is what's a 2. So all this being said, let's solve for n. It's a 4-mark question, so we don't want to overthink it also. And these are the kinds of questions, if it's not your cup of tea, reading it, it seems like your mood is just all over the place. Just move on and come back to it later. So here, n over 2, you have 2 here, negative. If you multiply the n inside here, 2n minus 2, this is 250. And then obviously, if you look at it nicely, right, you're going to have here 2 minus 2, that's just a 0. And then you have like n over 2, this is like that here. This is like n over 2 times 2n. Now, if you multiply these, you're going to have 2n squared over 2. This is like 250, right? And then obviously, if you think about it, this can cancel that out, n squared, 250. Now, the square root of 250, yeah, we're not going to use plus minus here because, I mean, like, logically speaking, our value of n cannot be a negative. You see, we only need to be working with positive numbers. So since we know that we're only working with positive numbers, the big idea here is we are obviously also not getting a whole number here as an answer. It looks like we're getting some kind of a fraction. We're getting some kind of a fraction. Now, the fraction that we're getting here is obviously, fortunately, not too it's not too weird looking, but I mean, like, it is what it is. Let's just see what number we're gonna get here in our calculator. So for this particular question, right, the value that we're getting here, let's see in the calculator here, we're getting 15.8, right? So this is like 15.8. in the calculator. So what this means is, logically speaking, for us to get 200, for us to at least add up 200, for us to at least add up numbers until it gives us 250, we have to add up what you call 16 terms in this sequence. So let's see here, 16 terms. Terms have to be added in the sequence of first differences. So me writing 15 here that time, that was a purely a coincidence. So since we now know that you have to add up at least 16 terms, because I mean, like, you can't add up 15.8 terms, you have to add up a rounded number of 16. So since you're going to add up 16 terms here, it means that in the original sequence, you would need to have been working with 17 terms. So when they say determine the position of the first term in the quadratic number pattern for which the sum will be this, the first term will be at term number 17. Therefore, T17. You can just say therefore T17 as an answer, so that you don't like find yourself getting like, you know, lost in your own words trying to explain things that are just mathematical. So let's move on. 3.2 here says rectangles of width 1 centimeter are drawn from the edge of a sheet of paper that is 30 centimeters long, such that there's a 1 centimeter gap between the one rectangle and the next. The length of the first rectangle is 21, as we can see here. And then it says the length of each successive rectangle is 85% the length of the previous one until there are rectangles drawn along the entire length of AD. And then they said here, each rectangle is colored gray. Yeah. So what we can see is this one is 21, and then this is 85% of 21, and then 85%, 85%. So, I mean, like, since this is an arithmetic sequence question, you already want to think of this as some kind of a geometric sequence. If it says calculate the length of the 10th rectangle, what you want to think to yourself is this is just geometric, you know? So you have Tn is equal to A, Rn minus 1. So in this situation, A is obviously 21. Your value of R is equal to 0.85 because you're just multiplying everything by 0.85, because if you're going to start with 21, right, for you to get something that is 85% of 21, you have to multiply by 0.85 to get the next one. And then you keep multiplying by 0.85. So here we now need to find the 10th rectangle, right? So n is a 10. So here you're going to say T10 is equal to 21, 0.85. Then you can have n, right? 10 minus 1, which is a 9. 21, 0.85. You have a 9 here. So yeah, let's see what this gives us in the calculator. So in our nice calculator, we're getting here 4.86 centimeters. Fortunately, this is not physics, so you don't get really penalized for units. But hey, if you're gonna do physics and maths together, just get in the habit of writing your units. 3.2.2 says calculate the percentage of the paper that is colored gray. So if you're gonna work out the percentage of the paper that is colored gray, you need to add up you need to first work out the area of the whole thing, right? Which is just gonna be 21 times 30, because area of A, B, C, D is just equal to length times breadth, which is equal to 21 times 30, right? So this is your area of the entire shape. So since we're working with the area of the entire shape here, the area of the entire shape is just what you may call 630. So my logic is we need to keep in mind that whatever area this is, right, the area of this shape here, logically speaking, you would be thinking to yourself, this area is just 85% of the previous area, and then you'd be thinking this is also 85%, going on and on and on. But we have to test that theory. You know, we really have to test that theory. But it is true, because the area of this shape is just 21 times 1, which is 21 centimeters squared. The area of this gray one is just 1 times the distance here, which is just 85% of the previous one. And then again, this is just 85% of the previous one, going on and on and on. So fortunately, our sequence is literally the areas of our different triangles also, because it's just length multiplied by 1 anyways. So the length of our different, rectangles. So the lengths of our different rectangles, if you just multiply by 1, it gives us the area. So what we're gonna need to do here is, if they're asking us what percentage of the paper is colored gray, all you need to do is you need to add up all these areas of your rectangles, divide them by the total area, and then multiply by 100. It's just like a mark for an exam. You take what you got, divide by the total, you multiply by 100. So the sum of the areas here is what we need to add up, the sum of the different areas. So us adding up all the areas together, what you do know is the first term is 21, and the number of terms that we're adding up, that's the question now. We need to know how many rectangles we're adding up. So logically speaking, you'd be thinking to yourself, okay, fine, there's one rectangle and then empty space, rectangle, empty space, rectangle, empty space, rectangle, empty space. Fortunately, what you do know is in every even number position, so this is at every odd number position, there's a rectangle. So you have a rectangle at 1 centimeter, and then at 3, and then at 5, and then at 7, all the way until like 29. So if we're going to start from 1 counting until 29, you are dealing with 15 numbers, you see, because it's like 1, 2, 3, 4, all the way into 29. That's like 15 numbers, which is half of 30. So you know that there are 30 rectangles to add up. No, 15 rectangles to add up. And then what you do know is your common ratio, as we said, is just 0.85. So this is not a difficult question based on what we've just said. A is a 21, R is 0.85, N is a 15. And then what we do know now is our R is 0.85, and then Sn is whatever Sn is. For Sn, we are trying to look for the sum of the first 15 terms, right? Yeah. So all this we have to put in the calculator before we get our percentage, obviously. So putting all this in our calculator, it is all nice, it is all dandy. We're getting here 127. Let's round it off to 2 decimal places. It's going to be 0.77. So your percentage is going to be 127.77 over 630. 630. So all this being done, the percentage there, you're going to have to multiply this number by 100. So let's see what this gives you. That multiplied by 100 is going to give us 20.28%, which is all good. So what we wrote here, we might as well just take it down here because it is good. So let's move on to the next question.
As of this recording, the all access pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the all access pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
Question number 4. Yeah, this question is very interesting. It's a normal exponential graph though, so let's take it nice and slow. It says here, sketched below is the graph of h. So this graph of h, we have an a value that is bigger than 0. Then they said here r is the y-intercept, okay. Then they said p is this point, q is this point, and then here it says here these are points that lie on h, which is the graph. So they said determine the equation, write down the equation of the asymptote of h. So fortunately it's an exponential graph. Because there's nothing directly next here, it just means our asymptote is a 0. So you have to say here it's a y, it's a line that cuts the y-axis at 0. So the equation is going to be y is equal to 0. A horizontal line will always cut the y-axis. So the equation of that line, you'll always say y is equal to whatever y value it will be cutting. So this, it's cutting the y value 0. So here they're now asking us to determine the value of r for also 1 mark. Getting the value of r is not difficult because already, the coordinates of r, right? Is it? Yeah, the coordinates of r. Automatically, we have the x value is just a 0. The y value is what we're missing. But fortunately, r is what? R is a coordinate on the graph. So since we're looking for a coordinate on the graph, it means we can use the equation of the graph. So using an equation of a graph to work stuff out, this is something that most people actually forget to do. But obviously, the more papers you're going to go through, the more memos you're going to go through, you'll see that getting coordinates is actually usually some of your easier questions. So in our equation, fortunately, funny enough, you'll be also thinking, but we don't have a full equation. This is where you going through multiple papers is going to help you. Because when you have gone through multiple papers, you'll already know that it doesn't matter if you don't have a. As long as you throw in a value of x as 0 here, you'll still get an answer. And that answer is just a 1. See, because if the x value is a 0, anything to the power of 0 is a 1. So your coordinate of r, x value is a 0, y value is a 1. That's why it's a 1 mark question. Now they're asking you to calculate the value of a. So the reason why they're asking you to calculate the value of a now is because they at least now know that you have something to throw into this equation for you to get a. You have a coordinate. But without worrying about the coordinate that you're going to throw in, it's not r because it don't work. This is the coordinate that you're going to use to get a. So you getting a, y is a 9, x is a 2. So here, obviously, you're going to get the square root of both sides, which is going to give you a plus or a minus 3. But then this is where the fact that they told you that a is a big positive value. No, they just said a is a positive number. That's how you now choose that a is a plus 3. And you don't have to worry about the plus and minus symbol. 4.4. Calculate the value of a again. No, 4.3, it looks like it came out twice. So oopsie. It's done in the previous question, maybe. So 4.4 says D is a point such that DQ is parallel to the y-axis. DP is parallel to the x-axis. Calculate the length of DP. We need the sketch here. So we need the sketch, and we obviously need to read the question again, like literally. It's a 4-mark question, so don't underestimate it either. Let's read again. It says D is a point on DQ. Okay, there's DQ. Okay, yeah. So there's D here, there's Q here. Q is a point on the graph. So say DQ is parallel to the y-axis. Okay, that's very important because what they're trying to tell us is if the x value here is a b, it means that the x value here is also a b. However, D in particular is directly next to P. Like they're aligned because they told us that DP is parallel to the x-axis. So if DP is parallel to the x-axis, it means that these have the same y value. If this is a 9, this is automatically a 9. If this is a B down here, this is automatically a B because it's directly upwards. So with all this being said, they said we should calculate the length of DP. So getting the length of DP, we have to get the x value B. Because if you get the x value B, you can easily just compare it to the x value 2, and then you'll have the distance. So our job is to just get B. Fortunately, you can get B using our equation of our hyperbola. Our equation of our hyperbola looks like this. We already know that this is a coordinate in the graph. So the y value is 1/81. The x value is at B. So if you're going to solve for B here, you can just use your calculator and also use logs. Since you want to isolate B, you're going to say B is equal to log. The base of your expression is a 3, and the value here is 1/81. So here, if you put everything in your calculator, you're going to get here negative. What negative is it here? It looks like -5. 1, 2, 3, 4, 5. Yeah. No, 4. 1, 2, 3, 4. It's going to be a 4. -4, actually. So here, B is going to give you a -4, which makes sense because B is on the left side of the x-axis. So if this is B, right, it means that D is -4 and, 9. So therefore, DP, right, what you're going to do is, remember the distance from here to there is just 4 units because distance has no regard for a negative symbol. The distance from here is just going to be 4 units. Distance from there is just going to be 2 units. Therefore, DP is a 6. So here, DP is equal to 4 plus 2, which is 6. The logic behind the 4 is the x value here. The logic behind the 2 is the 2 there. And fortunately, with maths and your memos, they will always have all that information for you to give you your marks. So out of 4, this is all you have to do. 4.5 though says determine the value of k for which this equation will have a root that is less than -6. This is not a pop and place type of question, but it's not too crazy. But we have to read it again. It says determine the value of k for which this equation will have a root that is less than 6. So firstly, we have to analyze what this means. When they say they want us to give a value of k for which this equation will have a root that is less than 6. So a root is just a solution to the equation. Secondly, the k here is just a movement from top to bottom. This is just a horizontal movement. It's not a vertical shift from top to bottom. You see, vertical shift. Vertical shift means this is moving the graph upwards. So apart from this moving the graph upwards, the 2 here, it shows that the graph has been moved 2 units to the left. Graph moved 2 units left. Before I proceed with this question, this is the kind of a question where, unless you're aiming for an 80 or a 70 or a 90, you don't have to worry yourself with these kinds of questions. As a matter of fact, if you're not aiming for an 80, you don't have to worry about these kinds of questions. But if you are, welcome. Let's deal with this question. It says determine the value of k. So they're asking you how many units up or down do you need to move your graph after it has been moved 2 units to the left. When all that is happening, what values of k can you consider such that the equation will have a root that is less than -6? So fortunately, in this situation, right, we're saying a root is a solution, but what we also need to know is that a root is normally an x-intercept. See, so without overthinking it, let's see if this graph is moved 2 units to the left. What's going to happen is this x value of 2 is going to be somewhere there. So let's see here. The original graph looks like this, right? So if you move it 2 units to the left, right, it's going to look like that. So this is what our graph looks like. after it has been moved 2 units to the left. After it has been moved 2 units to the left, you have to consider that, let's just take note of certain key elements of this graph that has been moved. This x value is now at 0, the y value is still a 9. This value of q initially started at -4 and 1 and 1 over 81. So when it's moved 2 units to the left, that point is going to be somewhere here. And the coordinate there is going to be -6 and still 1 over 81 because it was not moved up or down. So the idea now is, once it has been moved to the left 2 units, they are saying now, how many units up or down do you need to move it for the x-intercept to be less than -6? So the idea is, this is where your x value is going to be equal to -6. Now the idea is for you to have an x-intercept that is below -6. You can see that if it is a matter of how many units up or down you have to move your graph, the only way your x-intercept is going to be equal to -6 and eventually be something that is smaller than -6 or anything like that, it's if you move the graph downwards. What I mean is, if you're to move this graph upwards, there's no ways it will have an x-intercept. You see? So for you to have an x-intercept, you have to move it downwards. But the fortunate thing is, if you move this graph any amount of units downwards, it will already start to have x-intercepts that are below -6. And here's proof of that. You can see here, we said our graph, when it is moved 2 units to the left, it still just has the original asymptote, which is y is equal to 0. But the moment you move it any amount of units downwards, what's going to happen is, anytime you move it any amount of units downwards, right, this graph here is automatically going to start touching the x-axis. It's going to be touching the x-axis at a position that is always going to be below -6. The x-intercept here will always be below -6. And if you keep moving it downwards, up until you've moved it downwards a maximum of 1 over 8 units, it will always have an x-intercept that is below -6. The moment you move it anything more than 1 over 8, 1 unit downwards, it will start to have x-intercepts that are bigger than -6. So to answer this question, right, for it to have roots that are less than -6, we can only move our graph a maximum of 1 over 81 units downwards, and we have to move it nothing less than 0. So k here, right, we have to show that k has to be a value that is moving the graph downwards. So if your graph is moving downwards, k has to be a negative number. So here we're going to need to say that our value of k, firstly, it needs to be below 0, right? Because if it's above 0, it's going to be moved, the graph is going to be moving upwards. We cannot have it moving it up. We cannot have our graph moving upwards. Our graph has to move downwards. So k has to be below 0, but k has to be bigger than -1 over 81. The reason why it has to be bigger than -1 over 81 is because if you're moving it downwards, right, and your total amount that you can move it downwards is 1 over 81, what you need to keep in mind is anything bigger than -1 over 81 is going to be a distance that is smaller than this value. And any distance that is smaller than this value, or yeah, any distance that is smaller than this value, it means that your graph will be touching the x-axis at a value that is below -6 all the way until you've moved it down until your x-intercept is -3. So this question is only out of 3 marks. But again, if it is the kind of a question that you're not liking, sort of like is going over your head, don't stress too much about these kinds of questions, because this is not like where you bank your marks. This is just where you solidify like a distinction or something, because they're not like everyday questions. So that's how you answer these kinds of questions. You see, it's not too crazy, not too major, but that is that for this question. So let us move on with our exam paper.
As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
Question number 5 says the following. Sketched below is the parabola f with the equation this. Then it says here, and a hyperbola with this equation. This looks so familiar. So we have a parabola. Yes, it's a frowning parabola. The y-intercept is a -3, so that's very important. So -3 over there. And then they told us here that our hyperbola is given by this equation. So that's quite interesting. So it says here B is the turning point of F. Yes. So B is the turning point. Then it says here it lies on the point of intersection of the asymptote of G. So whatever asymptotes we have here, the x, the y asymptote and the x asymptote, they meet at B. And then they said A is this coordinate. It is the x-intercept of G. For 2 marks, they said show that the coordinates of B are 2 and 1 for 2 marks. So this question, it may seem quite straightforward because it is. So if you're going to get the coordinates of B, fortunately B is a turning point. Now, if you know how to work out a turning point of a cubic function, then obviously getting the turning point of a parabola is the same thing. Because when you need to get the turning point of any graph, all you need to do is you need to differentiate that equation and make it equal to 0. You differentiating it and making it equal to 0, you're basically looking for where the gradient is a 0. Or rather, you're looking for the x value where the gradient is a 0, because the x value where the gradient is a 0 is the x value of the turning point. So we're getting the x value of the turning point first, right? Which we're going to get to be a 2. Once we get that x value of 2, we're going to now sub it into the original equation, which is our coordinate equation. And then it's going to give us a value of y. See? So depending on what equation you use, it'll give you specific pieces of information. So this moves over to the left, right? This is like 2x, then there's a 4 here. Divide both sides by 2. You're going to have here x is equal to 2. So once you have an x value of 2, you can now just throw in a value of 2 into the original equation. So you're going to have here -2 squared. Negative with the 2 here squared plus 4 with the 2 here minus 3. 2 squared is like 4, the negative plus 8 minus 3. 8 minus 7 is a 1. There you go. So now we are good. So this is just going to say, therefore, B, x value is a 2, y value is a 1. Nothing too bad there. Nothing crazy. It's all good. They want us to determine the range of f. Range means how high or how low does your graph go. So this graph goes all the way to negative infinity, and it goes as high as a 1. So this range here actually has to be a 1 also. Whoops. The x value is the one that's a 2. So excuse me, x value is a 2, y value is a 1. So that's for the range. So this question is asking for which values of x will g of x be bigger than 0. So any question like this is asking you where are the y values of g bigger than 0. So g, what you can see here is that, yeah, you just need to be careful here. They're asking for which values of x will the y values be bigger than 0. So if you look at your image nicely, the y values are bigger than 0 over here. The y values are bigger than 0 over here. So if you're gonna give x values where your y values are bigger than 0, it's clearly an x value starting here, where x is a -1 going all the way to negative infinity. And then you also have y values that are bigger than 0, starting from where x is bigger than +2. So those are going to be your two sets of answers. If you're thinking of x values that are bigger than 2, you'll have y values that are bigger than 0. If you're thinking of x values that are below -1, you're getting these y values that are bigger than 0. You see? So when you give your answer here, you have to say that the x values need to be bigger than 2, or those x values need to be smaller or equal to -1. The reason why we're saying smaller or equal to is because of the question in itself. You see, the question is asking where would this graph be having y values that are bigger than 0 or equal to 0. Where x is -1, that's where it's equal to 0. Anything below -1, that's where it's below 0. Or rather, that's where your y values are above 0. Sorry, that's where the y values are above 0. And then anything where your x values are above 2, that's where you also have y values that are above 0 for your graph of g. 4.5 says, the rain. Determine the equation of the vertical asymptote of the graph of h if h is equal to this equation. So this equation is just g moved 4 units left. It's just g moved 4 units left. You see? So g being moved 4 units to the left, right? You have to think to yourself that the asymptote, right? Your vertical asymptote is the asymptote going from left, from top to bottom. So initially the asymptote is at +2. So if you move it 4 to the left, it's going to be at -2. So in this case, you're going to say, therefore, x is equal to -2. That's going to be the equation of your vertical asymptote. That's why it's just a 1-mark question. 5.5 here says, determine the values of p and t for 4 marks. We knew this was coming, hey? But anyways, if you're going to get the values of p and t, you may want to just work them out simultaneously. That's what I see here at first glance. But the thing is, well, let's see what we can do. This is our equation of g, right? Our equation of the hyperbola. In the equation of a hyperbola, we only have one coordinate that is very distinct. Fortunately, we also have the asymptote, like where the asymptotes meet. So that may be able to help us in some way. So my instinct here is to try and make sure y is the subject of the formula. It always makes things a bit normal looking. If you're gonna make y the subject of the formula here, you're gonna divide both sides by this bracket first. Now you may be asking, why are you making y the subject of the formula? The reason I'm making y the subject of the formula is because I want this equation to look normal. If it at least looks normal, we have at least somewhere to start. And we may actually be able to work out certain things without thinking too hard. And this is, you can see the method to the madness. If you move the t over, you can see why we want to get y on its own. Because the format here is the structure of the hyperbola. Any hyperbola, right, will always be equal to A over X minus P plus Q. Now, what we know is P and Q will always be giving us the equations of the asymptotes. So fortunately, we already know that the negative P here is going to represent the X asymptote, the negative T here is going to represent the Y asymptote. So the Y asymptote is at positive 1. So here, if you're going to get a plus 1 here, right? So you know that negative T is equal to plus 1. It means that T is equal to negative 1. Because if you throw a negative 1 there, you'll have negative times a negative, which is going to give you a plus 1. So this whole spot here, there has to be a plus 1 there because of our image. The X asymptote is a positive 2. And remember, with the X asymptote, you always choose the opposite. Meaning, if you see a minus 2 here, right, you will be seeing a plus 2 on the picture. So what we know is where we see this minus P here, in this very spot, you would need to be seeing a minus 2 over there. So in this case, it means that our value of P is going to be equal to 2. Because if you throw a 2 there, it will be negative times the 2, which is a negative 2. So we have 2 for P, and we have negative 1 for our value of T. So all this being said, you can see that it is all good. It is all nice and dandy because life is good. Let's move on. 5.6 looks like the kind of a question that we all just need to know to answer. The reason I'm saying it's the kind of a question we all just need to know to answer is because, wait, what is this question now? 4. This 5 point what? Yeah. So this question here, right, is the kind of a question that we all. Okay, actually no. If you're gonna be aiming for a distinction or a 60 or like a high 70 and 80 upwards, fine. These questions are important, but they're not everyone's cup of tea. So again, you only tackle them when your whole paper is done. This kind of a question does need us to have the picture, because the picture is gonna help us to show that this question is every math question, especially functions and graphs. If you can understand the logic behind what they're asking, you'll see that their questions are more straightforward than you think. So let's analyze what you do with a question like this one. If you've gone through multiple past papers, you already know that all you do with this situation is, if they're asking us to write down the values of x for which this multiplied by this is bigger or equal to 0, what you do is, there's an expression here being multiplied by an expression there. They're asking you, if you're going to multiply these two expressions, where will you have a number that is bigger or equal to 0? That's the question. If you're multiplying two things, where will you have an answer that is bigger or equal to 0? The only time where you have an answer that is bigger or equal to 0, right, is if you're taking the first thing that's a plus, you're also multiplying something that's a plus. Or you're taking something that's a minus, you're multiplying by something that's also a minus. These are the only times where you're going to get something that is bigger or equal to 0. Obviously, for it to be equal to 0, one of them has to be what you may call equal to 0, but you don't have to worry about that. Let's actually even only consider this for now, because you working out where this is equal to 0, that's a bit easier to work out when you understand what we're about to talk about now. So you working out where this expression is bigger than 0, you have to work out where each of these is a positive number or where each of these is a negative number. So what you need to understand is, when you see f of x is representing y values of f. G with prime here, or G with this apostrophe, this is representing the gradient, right? The gradients of G. So we're thinking of signs here. Where is something a plus, where is something a minus? When we think of y values of f, you have to remember that all these y values here are negative. All these y values here are also negative. You see? So let's maybe even color code it so that it looks like what we are at least trying to be working with over there. See? So with what we have just said right now, right? This is where your y values are negative. This is where your y values are negative, and then on top here is where your y values are positive. You see, this is where your y values are positive. Plus, for the graph of G, we have to be talking about its gradient. So the gradient of G, right? You have to remember that you have to look at your curve as though you're walking on it, coming from the left side to the right side. So this curve here, you're going to be walking downwards, you see. So the curve has a negative gradient. All this is negative gradient. Here you're also going to be walking downwards. So all this is negative gradient. So what that tells you is there's no scenario where you'll have positive times positive. This one is already cancelled out because you can never have a positive gradient. However, what you now want to look for is where you have y values of f that are negative together with a scenario where you have the gradient of g being a negative. So in that situation, you want to find out which x values is that happening. It's obviously happening up until this x value going to negative infinity. I mean, coming from negative infinity. From negative infinity up until this specific x value here, we can see that you have negative y values here while having negative gradients. So our job here is to work out this specific x value. You see, that's the first job. So working out this x-intercept, you can actually just use your quadratic formula. So we need to get the equation of our graph, obviously. So let's get the equation of our graph. Getting the equation of our graph, we want to get the x-intercept, right, of this parabola. We want to get the smaller x-intercept because there's two of them. Getting the x-intercept, you see, we're going to say x equal to minus b plus minus b squared minus 4ac over 2a. Now, in this situation, b is a 4, and then you have b squared here. A is a negative 1, c is a negative 3. And then a here is a negative 1. So in this situation, you want to see what your x-intercept is. For you to find out what your x-intercept is, you can just get that in the calculator. The calculator is giving us first x value is a 1, other one is a 3. Makes sense because you see, this is at least after 0. So this is a 1, this is a 3. We're only concerned about the 1. So fortunately, we can say that anything from negative infinity up until 1 is going to satisfy this equation. We might as well just do this. And we also need to keep in mind that if you're gonna say where will this expression be bigger than 0? It's where your x values are smaller or equal to 1. The reason you're saying smaller or equal to 1 is because at positive 1, you have a y value of 0 here. So 0 times anything will give you a 0. And then anytime you'll be thinking of x values that are below 1, you'll be having these negative y values together with you having these negative gradients here. So that's why your answer here, you have to say x is below or equal to positive 1. However, you may be thinking to yourself, but fortunately, the other side also qualifies. Because coming from 3 going onwards, you have negative y values here while having negative gradients. So that's something that qualifies also. So you also have to edit x here has to be bigger or equal to 3. That's how you work out these kinds of questions. And it's only now before I was about to move on where I'm like, wait, but the other side we also have what you may call, we also have a positive, we also have a negative y values together. We also have negative y values together with negative gradients. So this is like higher order questions. If you're aiming for a distinction, higher 70s, mid 70s, yeah, you can be going through these questions. If not, bank time by moving on and coming back to these kinds of questions.
As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
Go to negative x plus 3 and you have a log graph out. So for 4 marks per CD on the same set of x's, sketch the graph of f at g, clearly showing our intercept with the x-axis. No, actually clearly showing our intercept with the x-axis. So when you draw graphs like this, that obviously, fortunately, your question is quite straightforward. For 4 marks, you can imagine in total it's like 2 marks for each graph. So the idea is you have to understand, firstly, the straight one is the easiest one to draw. The y-intercept is just a positive 3. So up here, you're going to put a plus 2. Now, what we know is this graph has a negative gradient. So automatically, you can even just draw what the image looks like. It's going to look something like that. However, we need to find the x-intercept. To find the x-intercept, we're just going to make y a 0. And you're going to have 0, put negative x plus 3. The x goes over, the x is a plus 3, coincidentally. With a log graph, the idea is a log graph, it's usually just the inverse of an exponential graph. So normally what you do is when you need to draw a log graph, what you can do for yourself is you could actually just put stuff in your calculator, like values for x going from the left side to the right, and then you'll see how your shape behaves. One way that I also like to draw a log graph is, one thing we know is that a log graph is just the inverse of an exponential graph. So what you can actually do is you can see what the inverse of this stuff looks like, and then you can like reverse engineer it, draw this log graph. Example here, you can make this x, and then the x you can make it y. If you're gonna make y, that's subject to the formula. Remember, the idea is this is the base, this is the exponent. So you're gonna have 2 to the power of x, and that's gonna be your equation of y. So this equation on a Cartesian plane, if the x values are increasing, your graph would look something like this, going upwards. Okay. And its inverse would have looked something like this. So if this is the equation of 2 to the power of x, the equation of log 2x would look like this one. Yeah. So you know your graph looks something like that. So all you need to worry about is getting the x-intercept. Getting the x-intercept, we can make y as 0. This is 0 log with the 2 there and the x. This is a base, this is an exponent. 2 to the power of 0 is x, x is 1. There's the point. And then you just draw your curve. And then when you draw this curve, you obviously just need to label this one. There you go, positive 1. So all that being done, you can now keep in mind the fact that we can just move on without worrying about whatever it is that we have just done, because everything is fine. You can just label the 3 equations. This one you can label it Q of X. This one you can label it X. There we go. Moving on. So we have here 6.2. 6.2 says the following. Write down the equation of the inverse in the form y. So I feel like we already answered this question, but we might as well. So you're gonna make this. This is what we look at it as, right? But then now we want to solve for x and y. You see? So we're gonna say here x becomes y, y becomes x. So what happens is this becomes x, and I have log here with the 2 and then this is the y. And then you're gonna have here the base, this is the exponent. Y is equal to 2 it's gonna be worth 3 marks. 3 marks, it says explain how you will use 6.1 or 6.2 to solve this equation. So if you look at what g of x looks like, right? G of x looks like this. G of x looks like log 2 with x here. The straight line equation looks like is it f of x? Yeah, the straight line equation was f of x equal to negative x plus 3. F of x equal to negative x plus 3, right? So if you look at this statement or this expression, what you can see here is log with the 2 and 3 minus x. There's a 2 here, right? And then there's an x here. So remember what we say is anytime you wanna not have the log, if you wanna remove the log, you have to say this is the base, this is exponent, this remains on its own. So you're gonna have 3 minus x equal to 2 to the power of x, right? Now, funny enough, you see this is the equation of the straight line, negative x plus 3 equals to 2 to the power of x. So now you can easily answer your question. And you can say here, explain how you would solve this equation. So you'd solve it by, how would you use 6.1? So you would obviously use 6.1, right? Because the solution of the equation is where the graph of f meets the graph of g. That's what you'd say. The solution, yeah, okay, let's just refer to 6.1 specifically. So we can say here using 6.1, the solution of the given equation is the x value where the graphs meet. There we go. Moving on to 6.4. Write down the solution of this equation. Wow. Wow. So this equation, you're going to have to work it out using trial and error because you cannot necessarily like visually see where the graphs meet each other. So you have to use trial and error in your calculator because it's a 1 mark question anyway. So you're going to try out things like let x equal to 1. If x is 1 here, you're going to have negative 1 plus 3 is equal to 2 to the power of 1. This is a 2. This is a 2. So therefore x equal to 1. That's how you work out a question like that. Let's move on to question number 7. Question number 7. It says in June 2016, a bank granted Tabiso a loan of 200,000 at an interest rate of 15% per annum compounded monthly to buy a car. Tabiso agreed to repay the loan in monthly installments commencing on 1 July, so he didn't skip any payments. And 4 years later, on 1 June. However, Tabiso was unable to make the first 2 payments, so he now skipped and only commenced payments in September. Calculate the amount Tabiso owed the bank on the 1st of August, a month before he paid his first. So his money gained interest for 2 months before he started paying for it. So if an amount is going to gain interest, we have to use the compound interest formula. So our n is 2, so it gained interest for 2 months. Interest rate is 50% per annum. A is the value that we're looking for. So here A will be equal to 250,000. Interest is just 15% over 12, 14 to the power of 2. So this value in our calculator, let's see what it gives us there. So in our calculator, we are getting here 256,289 point, round off to decimal places, you're gonna have 0.06 over nothing paid. This is what he owes now after those 2 months. It's easy. Having paid the first installment on this 1st of September 2016, Tabiso will still pay his last month's installment in June 2020. Calculate the monthly installment. So the idea now is, of the 4 years, right? In total, he had 48 months to pay, but now he skipped 2. So 48 minus 2 gives us 46. So he has 46 months to pay. Yes, 46 months to pay the 256,000, 200, I think 289. Yeah, he has 46 months to pay that money. So since he has 46 months to pay that money, it's just a normal compound interest formula question. Because with this normal compound interest formula question, we just have to work out a value of x with all the other information that they have given us. So let's see what the value of x is going to be. So here, e is equal to x, no, 1 plus I minus 1. Is it really like this? No, it's not, bro. It seems so wrong. When your formula just seems so wrong, man, your best bet is to just look at the formula sheet. Because this formula, you don't have to cram them. Your formula sheet will always just give you the answer, what they look like. So here, since we're going to solve for x, just isolate x. I like to isolate x because they like multiplying both sides by the interest, right? Then we're going to have here pi is equal to x 1 minus 1 plus I to the power of negative n. So here you can divide the whole thing by the big bracket. Do that on both sides. 1 minus 1 plus I to the power of negative n, 1 plus I to the power of negative n. This cancels out now. See? Now this bracket is gone, the whole thing gone. So doing this, you have isolated x. So meaning you can now make x subject of the formula. You can make x subject of the formula. Now, making x subject of the formula is what we just done, right? X is going to be equal to whatever this value is here, whatever everything is here after you put in the necessary numbers. So, as we said, the loan is the 256,800 and 289 and 06, right? And then our interest is 15% per annum compounded monthly. And then what we know is that this is all giving us the value of x. So with a situation like this one, obviously everything is all nice, right? We just need to make sure that the stuff that you put in, you gotta make sure that you put in correctly. Otherwise, you're going to now face an unnecessary problem. In the calculator, we're getting here 7,359 points. If you're gonna round it up to 2 decimal places, that's his monthly installment if he wants to pay off the loan in time. Tabiso paid 9,000 as his monthly installment starting the 1st of September. How many months sooner will he pay the loan? Well, that's simple. Now we have to work out n. So since we now have to work out n, we have to just isolate n first and then put in values into the calculator. So isolating n is not a issue. It is as normal as normal. So isolating n here same idea. First, you're gonna start by multiplying by I on both sides. Right? You're gonna have pi here equal to x 1 minus 1 plus I negative n. And then since we're solving for n, right, we're gonna now divide by x on both sides. We're gonna have pi here over x equal to 1 minus 1 plus I to the power negative. What I normally like to do in this equation is I like to take this thing here to the one side so that it becomes a plus, and then I like to take this to the other side so that it becomes a minus. And then, with that being done, you obviously now can isolate your n using log. This is the exponent, so you isolate it and then you say log. Whatever this base of this exponent is, the base of the log, and then this big value here is something on here. And then you're gonna multiply by a negative, right? If you multiply by negative, this becomes a plus, this becomes negative. So when you're now putting your values in the calculator, obviously this makes life easier. 1 plus 15% over 12, then you have 1 minus 256, 289 point what? 289 point 06, point 06, point 06. Interest 15% over 12. The value of x is 9,000. So n here, let's see what n is. Put everything in the calculator, find out what n is. So we should expect n to obviously be smaller than smaller than 56 and 46. So let's see what this gives us here. The two decimal places, 35.42. However, I mean, like, you have to round this upwards. Therefore 36 payments. Okay. This is to just say that the last payment is not going to be 9,000. Then here it says, if Tabiso paid 9,000 monthly. Wait, two questions that are repeating. No. Oh yeah, no. If paid 9, yeah, this is so expected. If he pays this 9,000, right? They're now asking us, starting on wherever, calculate the final payment. The final payment is a formula, you see. Final payment, it is always equal to your, the final payment on your loan. The formula is actually something you can always just remember. See? It's something you can always just remember. Because your final payment on the loan, what you just have to do is you have to work out the balance on the loan after the 35th. And then whatever that balance is, it has to gain interest for 1 month. That's how you work out the balance on the loan, or rather the final payment on the loan. You just have to work out the balance of the loan after 35 payments, and then you just need to make that value gain interest once, and then whatever your answer is, that's the final payment. So your final payment, let's just say it's gonna be A minus F, right? This whole thing here, you have to multiply it by 1 plus I. There we go. So A is your compound interest formula. P 1 plus I to the power n. And then obviously F is the future value I knew it's formula. X and then 1 plus I to the power n minus 1, whole thing over I. A here, you have this value, right? 256 something 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 256,289.06. Yeah, and then 1 plus the interest. And then n is the full number of payments, which is this 5. You see the full payments before the last one, which will be less than 9,000. This is going to be to the power of 35. This is A, right? Remember, you are taking A and subtracting F. So let's see here. Subtracting F, yeah, you can have to do it. 9,000 A 1 plus, no. Yeah, 1 plus the interest here over 35 minus 1 to the power of 35 is the whole thing over 10% of the plot. So the idea now is, remember, you're gonna put this thing in your calculator. The whole thing here, you have to multiply it by 1 plus the interest over just once. See? Put all this in the calculator. So putting all this into the calculator, yeah, it seems quite okay. Seems quite straightforward, nothing major. So in the calculator here, we're getting 3,782. To 2 decimal places, it's gonna be 0.14. There we go.
As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
Question number 8. Question number 8 seems okay. It says determine the first derivative from first principles. Determining the first derivative from first principles. This question is like it's basic. Normally, what you want to do is just find out what the answer looks like so that you know what you're working for. There you go. So, firstly, you're going to lay out your first principles formula. First principles formula is on your formula sheet also. So here, f prime is the lim h goes to 0, fx plus h minus fx. The whole thing here over h. Now, all this being done, x plus h, and then f of x here over h. The idea is, let's see, wherever x is, you have to put x plus h. So this is like x plus h squared. Then you're gonna have your 3 x plus h plus h. And then you're gonna have your 3 x times x is like x squared, x times this is like x h, another x h, and then h squared. Then you're gonna multiply the 3 inside, but these are just like terms. You're gonna have your x squared with the 3. This 2 is like 2xh times by the 3 is gonna give you 6. 3 times that is gonna be 3h squared. So that's what this is gonna be. You're gonna have your limit there, h equals to 0, 3x squared plus the 6xh plus 3h squared minus. So since this is minus f of x, we just have to say minus, which is minus 3x squared, the whole thing over h. Now, with the whole limit here, you have to keep that there until the end because you'll eventually need to throw 0 or h and this denominator. At the top, things have to be cancelling out, otherwise it's off. So here you are left 6h, 3h squared, the whole thing over h. you want to take out a h with a point factor. So h goes out, 6x plus 3h, the whole thing over h. The h's cancel each other out. So when these cancel each other out, you're going to have this 6x plus 8. And then now you can drop the 0 where the h is. Then you can have this of 6x as expected. 8.2. It's a 2-mark question. John determines. Ooh, this question now. John determines that the first derivative. John determines that this, right, which is the derivative of a certain function at x is equal to a. Or he determines the derivative of a certain function where x is equal to a and arrives at this answer. Then he says write down the equation of g and the value of a. So a situation like this one, you have to remember that whatever g is, right, g of x, let's sort the mark allocation. It's a 2-mark question, so we don't need to g of x or g prime rather is equal to lim h equals 0. It's like gx plus h here minus g of x, right, the whole thing over h. So this is what g prime is. But then what we're given here is that when you take the first derivative and you throw a in there, it will technically be looking like g with a plus h here minus g with a here, the whole thing over h. So obviously, if you now see that this that they gave us, right, is equal to lim h goes to 0. They told us it is equal to square root of 4 plus h, square root of 4 plus h, and then minus 2, the whole thing over h. So automatically in a situation like this, it's clear for us to see that this is equal to this, and then it is clear for us to see that this is equal to this. See, it says here write down the equation of g and the value of a. So obviously here we're gonna say the value of a. But why is it oh, it's a 2-mark question. The value of a is gonna be a 2. No. The value of h, when you put a in the equation of g, you get it. Whatever this is, it's equal to 2. Now, if you're gonna get the equation of g, what do we know now? What we know is if you take g of a plus h, and the square root of 4 plus h. This is saying, remember, in the equation of g, wherever x is, we're gonna throw a plus h in there. So this and this, they look alike. So in other words, here the a definitely representing the 4, and then our equation of g of x would need to be square root of x. Because if you throw a plus h here you'd have a plus h. So if a plus h is equal to square root of if g a plus h is equal to square root of a plus h, means that if this number here, whatever this number is, it's whatever this value is over there. So whatever this a is, it's whatever this 4 is over there. And we've gotten the equation of g, we've gotten the value of a, which is perfectly fine, given the circumstance. So a is a 4, and then the equation of g of x is square root of x. So let us keep things moving nice and in the right direction. So if this question is not like a cup of tea, don't need to stress too much about it because it seems like just a random weird question. Excuse me. The next one here for 4 marks to understand differentiate. We're gonna differentiate. Always put things in a format that we can differentiate. Like here, there's a 1, there's a 3. The 1 goes under the 3. Yeah. the 1 goes under the 3, which is quite interesting because now you're gonna have x to the power of, wait, what? Really? The 1? Wait a minute. If it was like this, the 2 would go under the 1. Yeah. Oh yeah, of course. The thing is, this here, there's a 2 there. I'm putting a 1 by mistake. The 2 goes under the 3. See? And then here, this will go up there. The reason for doing all this is because if you're going to differentiate the expression, each term needs to be in this format where we have a coefficient or a coefficient, we have a base, and we're going to expand this to the 3 elements. So here we need first to have that the 2 has to go under the 3 there. We now have a coefficient which is 1, we have a base which is x. So here, first to end up with that, this denominator has to go next. But if you do that, the exponent has to be given a negative, which now you can see coefficient base. Now we can differentiate. Differentiating, I'm gonna say dy over dx equal to this times 1, right? So x over 2. This minus 1, that's like negative 3 times negative 5 positive 15. Negative 3 minus 1, that's like negative 4. And then there you get your, how many marks? You get your 4 marks. Again, the reason why this is a 4 mark question is because, yeah, you're obviously going to get the marks for doing all those changes and everything, because that's stuff they expect you to at least know to do when it comes to being able to. The next question, it says g of x is to this, it is a tangent to this equation at x is equal to 1, calculate the value of a and b. It's quite straightforward because anytime you need to work with an equation of a tangent to a curve, the tangent and the curve, they share two things. They share a coordinate and then they share a gradient. So if you go through things like the online courses on our course website, this is like something you already know. So for you to sign up for the online courses, the link that is in the description, you will definitely not regret it. Because of this recording, there is a huge sale for the all access pass, which basically gives you access to everything on the website. It's literally going for 99 and 4 months access. That's if you sign up right now when the sale is ongoing. But anyways, you have here tangent in the curve, right? You say they meet where x is 1, at the end. So you need to work with two things, the coordinate and the gradient. So your coordinate is only useful if you use the coordinate equation. Your gradient is only useful if you use a gradient. So what we can do for ourselves is, in this equation here, it's too blunt, but this equation cannot help us get a full coordinate of the point of contact. However, this equation can help us get more information. So the reason why we want to get more information about the point of contact is because we can then at least use it in this equation to only have a and b as the only missing variable. The idea is, if you're going to work out two variables at the same time, you want to at least somehow end up with two equations that you can work with to get the missing variable. So here, you can work with it to get a full coordinate. You're going to put a 1 where x is. Remember, a coordinate that a tangent passes through is the same coordinate that the curve passes. So here, you're going to have your negative 8 plus 20, right? That's like 12. So this is negative 8 plus 20, which is just 12. So the big idea now is, with all this being said, now we can put something in here where we can say that the y value is 12, the x values are 1. So if the x values are 1, let's see what we get here. Plus b 1 plus 18 here. This is an equation that only has a and b, which is useful to us. This is 1 plus a plus b plus 18 equal to 12. And then, with all this being said, let's maybe isolate a. Oh, let's see which one. We can do any. 1 plus 18, that's 19. That 19 goes over. And 12 minus 19 minus b equal to 8. You're gonna have negative 7 minus b equal to 8. Okay, that is quite interesting. Negative 7 minus b is equal to 8. So now we can label this maybe equation 1. So what this does is you have to now think to yourself, okay, fine, like the coordinate has helped us. Now we need gradient. So the tangent and the curve share a coordinate. They also share a gradient at the point of contact. So what you do know is where the tangent meets the curve here, positive one, the gradient at that point is a negative. That's information you need. So for us to work with the gradient, what we know is gradient is equal to negative h, but then the x value is a 1. So we need a gradient equation of our curve. The gradient equation of our curve is the first derivative. So here we're gonna have 3x squared plus 2ax plus b. Now, for this being done, we now have a gradient equation where we can draw gradient. Gradient is minus h, x is positive 1, and then we will later on be able to bring our a value there. So here, this is 3 plus 2b, not 2a, plus b minus a. We're gonna throw a here. This is negative 7, negative b. It's like 3 plus 2, negative 7, negative 3 plus b is equal to negative 8. So this being done, let's just see what we can do now. This is like 3 plus multiply inside by we're gonna have like negative 14 multiply again, we're gonna have negative 2b plus b negative 8. So let's see now. Negative 8, negative 3 plus 14. This is like what? Negative 3. So I don't even know I'm using mental math here. It's like negative 11 here plus 14 equal to negative 3. Yo, this is like a 3. Divide both sides by negative, or negative 1 rather. You're gonna have b as negative 3. So since your b value is a negative 3, it's not easy to just go get a value of a. Because getting a value of a, you just need to throw in a coordinate of b in that first equation that we got. And then we'll be fine. So let's just do that. Negative 7 minus b is equal to a, right? Negative 7 minus b is equal to a. So we have negative 7 minus negative b is equal to a. Then here, what can I have here? Negative 7 plus 2. So negative 7 plus 2 is like what? Negative 4. Yep, that's what it is. It's negative 3 and negative 4. Those answers definitely look accurate. So we can definitely move on to the next question. Question number 9. We're gonna really we're diving into the full blown calculus. It says for a certain function f, the first derivative is this. Calculate the x coordinates of the stationary point. So the thing is, when they say x coordinates of the stationary point, they're talking about the turning point. So this is already the first derivative. So if you already have the first derivative, you just make it equal to 0. Put the x values of the turning point. Slash stationary. So here you can just get your values using the quadratic formula. B squared minus 4ac holding on to a. And here we have minus b plus minus b squared. B is like 8 squared minus 4a is like a 3. C is like a minus 3. A like a 3, and then what do we have now? So what we now have is follow. Put this in the calculator. Let's see what we're gonna get here. So for our first answer here, we're gonna get negative 3. X is negative 3. Or what the calculator gave us here, x is the third. So those are the two x values we can find. Which are the two x values? We have taken. It says for each values of x's is concave down. So the idea is, if you want to find out where it's concave down, firstly, what you already know is the way this is laid out. Firstly, you don't even know what kind of a cubic function you're dealing with. So let's not even try Cartesian here. But what you do know is, remember, if your first derivative has this as a positive number, it means that the original equation also had an a value as a positive number. Because this time, this, if it comes out as a plus, it means this is a positive value. So initially, you know that this is the equation of your cubic function. So if this is a plus, you automatically know that your picture looks like this. So if your picture looks like this, what you know is, if you're gonna work out where your graph is concave down, remember, knowing where your graph is concave down, it's all about knowing where the x value of the point of inflection is the point of inflection. So let's just say x value of the point of let's do the x value of the point, x value of the point. That's what this dotted line is. The fortunate thing is the dotted line where you have your point of inflection is actually in between your two turning points, your x value. So here you have -3, and then here you have 1/3. So in between of -3 and a third, that's where you have the x plus the point of inflection. The reason why that's important is because one side here, if the side that's frowning is the side that's concave down, the side that's smiling is the side that's concave up. We first need to find out where the middle is so that we can say the graph is concave down from whatever this x value is going to the left. So find the middle of -3 and a third. We just going to say the -3 plus a third. -3 plus a third. I mean, in the calculator, let's see what our calculator gives us here. Giving us -4 over 3, which is okay. No, -4 over, yeah, -4 over 3. -4 over 3. So now you're going to say, therefore, the x values are below -4 over 3. That way it's concave downwards. You see, it's concave downwards where your x values are smaller than -4 over 9.3 says determine the values of x to which the graph is strictly increased. So again, here you need to be able to visualize this step. And you also need to know the significance of all these. This is, we say the x value here is a third, x value is a -2. The graph is increasing where your y values are going upwards. The y values are going upwards here because you always look at your sketch from the left side going to the right. And they're also going upwards here because you always look at your sketch from the left side going to the right. So if you're walking, you're going to be walking up here until here. Then you start down again until here, then you start up. So the graph is increasing where the y values are going up. So the graph is increasing where our x values are below -3 or our x values are there. That's where the graph is quickly increasing. So that's why that's a 2-mark question. So if you go on the main channel, right hand, which is the main channel, because remember this is just like a secondary channel where we go through like full past pages on this specific channel. And then the main channel is right hand brains. Go on playlists, you will see here there's a calculus playlist. that calculus playlist, if you look at it nicely, kinds of things that it works on. Look at the kinds of questions here. Differentiating equation of a tangent that was asked. Again, equation of a tangent, determining knowing how to differentiating with surds. We definitely did that, and fractions also. And then here, this is just bonus, and then here, equation of a tangent. This is the calculus playlist. However, if you then go to the cubic functions page, that's where you find the gold now. Because the kinds of questions here, if you look down here towards the bottom, how to get a turning point, how to get the point of inflection, how to sketch a graph, how to determine the concavity of the graph, how to determine where it's increasing or decreasing. And you see how these towards the bottom are quite short and sticky. But that's all you need for this kind of question. Let's move on to 9.4 here. It's a 5-mark question. You say it is further given that this is the equation of f of x, and there's a point it passes through. This is clearly the y-intercept. The reason we know it's a y-intercept is because x is 0. See? Y-intercept because x is 0. Now they want us to find the equation of f. So in the beginning, you can already just say f of x is equal to ax cubed plus bx squared plus cx minus 18. This is now obsolete because it doesn't help us much. But what we do know is from this specific equation, we can only throw in, can't really do much because if we throw in x as 0, negative 18 will be left. So the way this equation is laid out now, it's quite useless. The only thing that's useful though is the first derivative that they gave us. The reason why this first derivative is useful is because we can somewhat reverse engineer our question for us to get for the equation of f. It's actually not even a difficult question. The reason why they're offering 5 marks is because of all the writing, and I guess they're also just being generous because it's not like a very, very straightforward question. We do need to think of it. So what we do know is this is our first derivative, right? So if you differentiate once, see what we have. But before we can worry about differentiating once and getting this, we can just use the generic equation with the variable. Because here, if you differentiate this, right, you're gonna have here 3a x squared, 2b x minus c. So the reason for doing this is so that you can see that the 2a, 3a there goes with 3, the 2b here goes with the 8, and then obviously the minus 3 here goes with the c. So now you can literally just work it out. 3a, 3, divide both sides by 3, a over 1. Here, 2b is equal to 8, divide both sides by 2, b over 4. Here, c is clearly a minus 3. So you have your full equation, not even a lot of people, if any. So f of x here, just gonna say it's equal to x cubed plus 4x squared minus 3x, and then our value of b minus 18.
As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen. Question number 10 here, right, says the following. It says here, the number of molecules, let's see it again. The number of molecules of a certain drug in the bloodstream a certain number of hours after it has been taken is represented by this equation. So this equation basically gives us the number of molecules of a certain medicine, right? After a certain number of hours. Now you have to remember this represents a cubic graph. It literally represents a cubic graph. So logically speaking, we would be expecting a graph that looks something like this, something like that. You know, in the sense that the molecules, they like go down, up, and then they eventually just go down in depth. But then it says here, determine the number of molecules of the drug in the bloodstream 3 hours after the drug was taken. So before we answer these kinds of questions, the one thing you want to understand here is that these kinds of questions, you need to know exactly what your equation gets you. So fortunately, this equation is a bit straightforward, right? If you give it time, it's going to give you the number of molecules in the bloodstream. That makes sense, right?
Yes. So I am putting the 3 hours in the T.
Yes. Yes, because this they're asking for the number of molecules, right? Number of molecules in the bloodstream 3 hours after the drug was taken. So this equation gives you the number of molecules if you give it time. So where T is, we're just gonna give it the number 3, and then after that, we're just gonna work it out. So M here, we're gonna put a 3 there, 3 there, 3 there, and then 3 there. So in this situation now, 3 cubed is 20. Calculator.
It's 216.
216.
Yeah.
What a wow. What a wow. Oh, I think the 72 is what's causing that. 216, right? 216.
Yes.
Yeah. So it then says here, what's the next question? The next question says the following. Determine the rate at which the number of molecules of the drug in the bloodstream is changing at exactly 2 hours after the drug was taken. So this is where your theory of words comes into play. When they say determine the rate at which the number of molecules in the bloodstream is changing. So you see, keywords here, rate of change. Now let's go deeper into this. Whenever you hear the words rate of change, what you need to think of is first derivative. First derivative. So that's like super important, right? That let's see. Yeah. So that's important, right? Rate of change is linked to what is this? To the first derivative. Because if you're gonna get the rate of change of something, you have to use the first derivative. Because the rate of change equation is things like gradient. So it's the same idea here. If you're gonna work out the rate at which the number of molecules is changing exactly 2 hours after the drug was taken, you have to use your first derivative. So your equation of M, we have to differentiate it. right? So I just want to put T where the 3 is, and then we'll differentiate it. So let me just remove this, and this. So I just want to put T here. So this is our original equation. So we need to differentiate it. So the first derivative of this equation is going to look like this: negative 3t squared positive 6t plus 72. You see it?
Yes.
Yeah. So with this being said, we need to put a 3 where t is.
Isn't it
Then
a
it's going to be no a 2, yes, because they said exactly 2 hours. Yes, thank you. Exactly
You're
2
welcome.
hours. Perfect. So if you put a 2 here, we can now then just put all that in the calculator. It's going to give us negative 3 times 2 squared plus 6 times 2 plus 72. That's an answer of, yeah.
Yeah, I
So,
get 72.
yeah. So that's going to be your answer. Okay. So you can see you don't have to worry too much. You can then just say you have 72 molecules per hour. If you just left it as 72, that's still fine. Still 100% A-okay, because you get your marks for the derivative, you get a mark for subbing incorrectly, you get a mark for the final answer. This is just extra information, just to be fancy. So this question says, how many hours after taking the drug will the rate at which the number of molecules of the drug in the bloodstream is changing be a maximum? So the rate of change equation is the first derivative, right? Which we have. We have the first derivative. However, if they are asking for where this rate of change equation is a maximum, what you do is anytime they ask for the maximum of a certain equation, you have to differentiate that equation first, and then you make it equal to 0. That's the issue here. We have a rate of change equation already, but because they're asking where will it be a maximum, we have to take that equation, we have to differentiate one and make it equal to 0. Because anytime they ask for the maximum of something, we have to take whatever equation they are talking about, differentiate it, and make it equal to 0. So it just so happens that the equation we're using here is already something that has been differentiated. It's okay, but that's what our rate of change equation is. It's our first derivative. So because they're asking where will it have a maximum value, you have to differentiate it and make it equal to 0. So this is going to be a 0. If you solve for t here, can I have 6t over here and then the 6 here? Divide both sides by 6. T is a 1. Of which, with what we had done, right, we had been looking for where the maximum and the minimum for the rate of change equation is. It's between negative 4 and 6. So negative 4 and 6, right, we know that between negative 4 and 6, you're going to get the 1. Because the rate where you have the maximum of the rate of change equation is the point of inflection. And the point of inflection is always in between the two turning points of whatever graph you'll be dealing with. So the idea with this probability question, right, from this 2016 paper 1 November paper, it says here a survey was conducted among 100 boys and 60 girls to determine how many of them watched TV in the period during which examinations were written. The responses are shown in the partially complete table. So people that watch TV during exams, males will tell you more than females. The total here is these two added together. Then it says it did not watch TV during examinations. There's a number here and a number there. And then this is the total. And then from left going to right, the total, we're going to write it here. From left going to right, the total, we're going to write it here. Yes. This is telling us we obviously have a total of 160 people.
Yes.
So with that being said, getting the values of A and B, as we said, it's just these two added up, which in this situation, I think it's going to be 128. If the calculator can confirm, let's see.
120.
Yeah. And then these two should add up to 32. So this by default has to be a 20.
20. Yes.
So we might as well just for the sake of it, put the total here, which is 100, the total here, which is going to be a 60. Okay. So that's what we need to keep in mind there. Now, with all this being said, right? 11.1, we answered. We said A is equal to 20,
20.
and then B is equal to 128. Yeah. So 11.2 says, are the events being male and did not watch TV mutually exclusive? Give a reason for your answer. For mutually exclusive events, what we know is the probability of A multiplied by the probability of the probability of A and B is equal to 0. You see, that's for mutually exclusive events.
Yeah.
So what we need to find out is the probability of being male. We need to get that value. Then we need to find out the probability of not watching TV. So let's say NT for not TV. We need to get these two probabilities, right?
Yeah.
But the thing now is, once we get those two probabilities, what we need to keep in mind now is, this is a 2-mark question. So any 2-mark question, we really don't have to overthink it. So, but without being too, like as I'm saying, right, without overthinking it, right? Funny enough, fortunately, this year is obsolete. This year is obsolete. Our table can show us where you have males and not watching TV meet. So people that don't watch TV but that are male, you have 20 of them.
Yeah.
So the probability of finding a person that watches TV and is male, it's too high. It's 20 over 6. It's 20 over 160. So the probability of being male and not watching TV is equal to 60 over 1. Is it 120? No, 20 over 160.
Yeah.
Obviously, this number is not equal to 0. So
Levi,
what you have, yeah.
sorry, why do you use the 160 instead of the 100?
Okay, so the reason why we're not using the 100 is because this is the total males and not like everyone that we're dealing with. Because you see, remember here, the fact that a person does not watch TV, it's not about males only. It's about everyone. You see.
Okay.
Yeah. So they say are the events being male and did not watch TV mutually exclusive. So the did not watch TV part, you can see it shows you that you should be talking about everyone that you're dealing with. So that's why we're putting over the 160. And then that's giving us a total of 1 over 8. So here you can say 1 over 8 is not equal to 0. Therefore, events
Or not
are,
mutually.
yes, are not mutually.
Exclusive.
Yeah, that's right.
Okay. Got it. Yeah.
Yeah. Dot co dot z. Anyways, 11.3 says if a learner who participated in this survey is chosen at random, what is the probability that the learner watched TV in the period during which examinations were written? So we want the probability of people that watch TV during the exam. So the probability of choosing a person like that.
So wouldn't it be 128 over 160?
Yes, because 128 people is everyone that watch TV. So this definitely we can get it in its simplest form. We have 4 over 5. Yeah. 11.3.2 says is not a male and is not a male. Okay. This is not a male and did not watch TV in the period during which examination. Wait, what? Okay, there's a blanket question. If a learner who participated in the survey is chosen at random, what is the probability that the learner is not a male and did not watch TV? So we want to take into account everyone that is not a male and everyone that did not watch TV. So did not watch TV and is not a male. So it has to be a female that watched TV.
So
You get it?
then 12 over 100, no, can't be male. So then wouldn't it be 12 over 32?
No, no. In this case, you have to take it over 160, because the idea
Oh,
is
okay.
with your probability questions, you always put it over the total of everything. You would only put it over the 32 if they said something like amongst the people that did not watch TV, blah 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 blah. So here they're picking out from everyone. So you have to choose the 160.
160,
Because,
okay.
yeah, because they're saying here if a learner who participated in the survey. So remember, learners that participated in the survey, you have 160 of them, right?
Yeah.
Yeah. Is chosen at random. What is the probability that the learner is not a male? So we're looking for people that are females. So this is not a male and did not watch TV. So we want people that watch TV. So it's people that are females and watch TV. So the people that are females and watch TV, you have 48 of them. See, those are the number of females that are watching TV out of 160. So 48 out of 160 is what you're gonna put over there. And then with that being said, right, we just have to check what our calculator gives us in its simplest form, right?
Like 3 over 10.
Yes. Wait, 3 over 10. Oh, no, this is wrong. Wait, we said people that are female and what?
They do not
That,
watch. So
oh,
it's,
yeah, I chose watch. Yeah, it's supposed to be 12.
yeah, I saw it, but I wasn't sure then, and I thought maybe I read the question wrong. So then
Yeah, no, sorry. We want females that did not watch TV, because here it says did not watch TV. I don't know why I'm putting opposite here. I chose when I think what the mistake I done was when I was reading, I saw opposite of male. So here I also choose opposite of watching, of not watching. So which is the problem. But we want people that are not watching and are females. So it's just 12 of them.
yeah, and then that will give you 3 over 40.
Yeah, that's fine. The digits 1 to 7 are used to create a 4-digit code to enter a locked room. How many different codes are possible if the digits may not be repeated and the code must be an even number bigger than 5,000? So you see, we've just read the question. That's not good enough. We've just read the question, it's okay, but we now have to read it again while laying out the structure that's going to help us answer this question. I'll repeat. When we're reading it again, we lay out a structure that's going to help us answer the question. So a structure that's going to help you answer the question is basically linked towards what they're asking. So they're talking about us using digits 1 to 7. So you want to visually see what that looks like. There's 1, 2, 3, 4, 5, 6, 7. There's 7 numbers that we're using. They are used to create a 4-digit code. So what you do is you want to see that there's going to be a slot for this thing here, second position, third position, fourth position. So this is what our code is going to be looking like. And then they say here, how many different codes are possible if the digits may not be repeated? So you have to highlight certain things that are restricted. So digits may not be repeated, that's one thing. And then they say here, and the code must be an even number. So 2 things, no repeating, and it must be even. You see?
Yeah.
So what you do is, you see here, we technically have 4 limitations. The first limitation is the values that we can use. The second one is we cannot repeat those values. The third thing is the code must be an even number. Actually, no, this is the third one and the fourth restriction. The second restriction was the fact that it has to be a 4-digit code. Okay, that's the second restriction. The third restriction, digits may not repeat. The fourth restriction, it must be an even number. So what you do is you need to satisfy each of these restrictions one by one. So us knowing we have to choose numbers from 1 to 7, that's simple. Us knowing that our digit has to be our code has to be 4 digits, that's also simple. That's why we only put 4 slots. So we have satisfied this. This is easy to satisfy. This is already satisfied by default because we're only visually seeing 4 slots. Now, if they say that the codes are, they said here we need to, how many codes are possible if you cannot repeat and your code must be an even number that is bigger than 5,000. So we actually have 5 restrictions. The number has to be bigger than 5,000. So it being even is not good enough. It has to be even and it must be bigger than 5,000. So what you do is you want to satisfy the restrictions that are the most stringent, the most strict ones. Like for example, the it being 4 digits, that's the most strict one. So you already are only seeing 4 places. Secondly, the fact that it has to be bigger than 5,000. Do you see that it limits the numbers we can put in front here?
Yes.
Yeah, it means we cannot put a 1, we cannot put a 2, you cannot put a 3, you cannot put a 4, you cannot put a 5, you cannot put a 6 or a 7. So in a situation like that, right, where you cannot put 1, 2, 3, or 4, you can only put a 5, 6, or a 7. So what you do for yourself is when you work out questions like this, you almost need to put yourself in the situation where you will be saying to yourself, okay, fine, I need to make a decision as to how many options can go in here. That's how these kinds of questions work. You work in terms of how many options can you place in a certain position. So you say to yourself, how many numbers can potentially be in here? It cannot be 1, 2, 3, or 4. The numbers that can potentially be here, it's only 5, 6, and 7. Do you agree?
Yes.
Yeah, because the number has to be bigger than 5,000. So since it can only be 5, 6, or 7, it means that here you only have 3 options. You get it? There's only 3 options for that place in the beginning.
Yeah.
You
So
get it? Yeah.
basically, I'm not putting in numbers, but I'm counting the amount of numbers that can go in there.
Yes. Yes.
Okay. Makes
Yeah.
sense.
So that deals with this factor here. Now, the other thing is, if your number is going to be an even number, it has something to do with what goes at the end here. Do you agree?
Yes.
Yes. So if your number is going to be an even number, you see that there are only what you call 1, 2, 3 options for the back here.
Yes.
Yes, you know that there are 3 options for the back.
Yeah, because it's
But
going to
then
be an even number as well.
yeah. But then now when you get to this point, you start to wonder and you're like, but wait, what about scenarios where the beginning is a 6 or something like that? Because if the beginning is a 6, it means that the end can also not be a 6. So we would not necessarily have 3 options for the front and 3 options for the back. So in a situation like this, you're seeing that the question is just becoming a bit difficult for you to like work out just by using an image like this. So in a situation like that, what you have to do is you have to think to yourself, okay, fine, the front here only has 3 options. So you might as well lay out the 3 different kinds of numbers you can have. You can either have numbers that start with a 5, and then you have numbers that start with a 6. Lastly, you have numbers that start with a 7. This is how you can now look at it. To say that, okay, fine, instead of just looking at it in terms of one picture that you're going to use to help you answer your question, you can look at it as 3 pictures. To say, let me count how many options we have for numbers that start with a 5. And then you count how many options we have for numbers that start with a 6. And then you count how many options we have for numbers that start with a 7. Do you see that?
Yes.
Yeah. And us making this decision, it's because of the fact that our restrictions are a bit many. So for us to go around the fact that a number cannot be repeated and our number has to be even, it looks like it's best for us to see that, okay, let's work out the total number of options we have for numbers that starting with 5, starting with 6, starting with 7. So let's deal with the one starting with a 5. So the number starting with a 5, you know that in the beginning here there's only one option. You can only put one number in there, which is the 5 that we're talking about.
Yeah.
Secondly, we need to now think to ourselves, okay, fine, this number has to be an even number. So logically speaking, if it starts with a 5, in the back here we have 1, 2, 3 options. You see, we can either put a 2, a 4, or a 6, so we're safe. And then now you ask yourself, okay, fine, once you put a number in the front here, and once you put a number at the back here, you have used up 2 numbers out of the 7. Do you agree?
Yes.
Yeah. So if 2 numbers out of the 7 are used up, it now means that for this position here, you only have 5 options. And then once you put a number in here, you only have 4 options for this one. So that's how you work out your total number of options for a specific slot in your question. You don't necessarily have to look at it from left going straight to the back. You have to satisfy your restrictions first. So the first restriction was it has to be 4 digits, so we put 4 positions. And then secondly, we want to think of numbers that are bigger than 5,000. So we're starting with ones that start with a 5. So we put a rule to say there's only one option for the front here. And then the back, if you're gonna start with a 5, you can still end up with a 2, a 4, or a 6. So we have 3 options in the back.
Yeah.
And then the logic behind that, we said, okay, fine, once you put a number in the front, and once you put a number at the back, you only have 5 options left for this position here. And then you have, once you put a number here, you only have 4 options here. You get it?
Yes, I get it.
Yeah. So it means that for numbers that start with a 5, these are your total outcomes if you multiply these numbers. So you do the same for the 6 and the 7. Now, when you do the same for the 6, you ask yourself, okay, we want to find out how many numbers start with the 6, right? So us finding out the numbers that start with, let's see here, us finding out the numbers that start with, let's see, let me see here, let me see here, let me see here, yeah. So us thinking of numbers that start with a 6, right? We need to ask ourselves, there's only one value. In the beginning, there's only one option. Once you put a number 6 in front, for the back here, you only have 2 and 4 as options.
Yes,
you see that?
because you've used 6 already.
Yeah, yes, because numbers cannot be repeated. We have to work simultaneously. We have to satisfy all the restrictions. Okay. So the next thing now is we're gonna say to ourselves, okay, fine. Once you put a number in front here, once you put a number in the back here, you only have 5 options for this position, right?
Yeah.
You agree?
Yes.
Yeah. And then once you put a number here, you only have 4 options for this one. You agree, right?
Yes.
Yeah. So with all that being said, you can now just think to yourself, okay, fine. The number of options here is just 1 times 5 times 4 times 6. And then you move on to the 7. You do the same thing. Numbers that start with a 7, there's only one option in the front. Once you put a 7 in the front, for the back, you still have 3 options because you have 2, 4, 6. Once you put a number here and here you only have 5 options now, and here you only have 4 options. So now you add up these totals here. So all these, the number of options for the 5, the number of options for the 6, the number of options for the 7. This is like 20 times 3, which is a 60.
Yes. Next
I mean,
one's
this is okay.
40. Yeah, 60 and then 40.
So it's going to be 60 plus 40 plus 60. Yes, it's 160.
As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, The All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen. There we go. So if you finish the whole paper, then wow, that's amazing. Now, depending on all that you've learned within this question paper, the one thing that you definitely want to do for yourself is you want to sign up for the online course on our website. Because the online courses basically have detailed examples and detailed explanations of all that you need to know within the syllabus that you are working in. So the online courses are definitely IEP and CAP compliant.